Hi, this is Alex from devstories.eu. Databricks, episode 5 of 15. You can easily restrict who sees a column in a relational database, but how do you enforce access control on a cloud storage bucket full of thousands of raw PDFs? The answer is taming unstructured data with volumes. Before we get into how they work, let us clear up a common mix-up. Volumes are strictly for path-based file access. They are not for tabular data. If you are querying rows and columns with SQL, you use a table. If you are reading images, text documents, or audio files, you use a volume. A volume is an object inside Unity Catalog. It represents a logical storage space in your cloud environment. By creating a volume, you bring unstructured data under the exact same security umbrella as your structured tables. Instead of managing identity policies in AWS or role assignments in Azure just to read a file, you control access using standard permissions directly in Databricks. Consider a hospital training a machine learning model to detect anomalies in X-ray images. They cannot put thousands of high-resolution images into a database table. They need to store them as raw files in cloud object storage. Because these are highly sensitive patient files, strict governance is critical. By placing the X-rays inside a Databricks volume, the engineering team can govern exactly which data scientists are allowed to read that specific directory. There are two types of volumes, managed and external. A managed volume is completely handled by Databricks. When you create one, you do not specify a storage path. Databricks simply carves out space in the default storage location assigned to your current schema. You upload files directly into it. If you ever drop a managed volume, Databricks deletes the underlying files as well. This makes them ideal for temporary workspace files or data generated entirely within your Databricks pipelines. An external volume points to an existing cloud storage directory that you already own. First, you register a cloud storage path as an external location in Unity Catalog. Then, you create a volume on top of it. This gives you strict governance over data produced by other systems. If a separate application writes log files into an Azure Data Lake bucket, an external volume lets Databricks users read those files securely. If you drop an external volume, the metadata is removed, but the underlying files in your cloud bucket are left completely untouched. This path-based approach is exactly what modern AI requires. Open-source machine learning libraries typically expect to read data from a local file system. They do not know how to authenticate with proprietary cloud storage interfaces. Volumes solve this by exposing a directory path that looks and behaves like a standard local folder. Your model training script simply opens a file path, Unity Catalog intercepts that request, and seamlessly verifies the user permissions. Here's the key insight. Volumes eliminate the disconnect between how you govern your structured databases and how you secure your raw files, allowing you to run machine learning workloads on unstructured data without bypassing enterprise security. That's all for this one. Thanks for listening, and keep building.